Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over simplifying radicals. So first of all, when we use that term radicals, what are we talking about, and what are the parts to a radical expression? So here we have a big radical. Sometimes we see a little tiny index number here, that n, in between that little radical sign. Sometimes we don't, and we're going to talk about what that n represents. So first of all, when I'm talking about radicals, the actual square root sign, that is what we call the radical. The number that is underneath that radical sign, so in this case, this variable a, that is what we call the radicand. So we have known in the past with these square root signs, we are trying to find what number times itself times the exact same number equals that number under the radical sign. So that a variable is called a radicand. Then the number that is in between, it's real tiny in that square root sign or that radical sign, that is what we call the index. So if there is no index, so usually, most often, we don't see any number there, it is assumed it's kind of invisible that there is a 2 there, that we're taking the square root. The second that that number changes, so if we see a 3 there, that'd be a cube root. If we see a 4, it's 4th root, 5th root, 6th root, so on. Okay? So if a radical has more than one root, the radical sign indicates only the principal or positive root. So if there's no sign in front of the radical sign, so if we just see the radical, then we're looking for the positives. If we see the plus minus sign in front of the radical sign, well, then we know it's the positive and the negative. There would be 2 solutions when we see that plus or minus sign. And then if the negative sign is out front, well, then we'd have a solution and it would be a negative. All right. Knowing the perfect square roots or the perfect squares is going to be extremely helpful for simplifying radicals. So let's list out the perfect squares. We're going to list out the first 12. So what that means is 1 times 1. So a square is 1. 2 times 2 is 4. 3 times 3, 4 times 4, and so on. All of these are perfect squares. And then they're also perfect square roots. So 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. We're going to go to 12. So there are the perfect square roots. And we could keep going on and on. There are more, obviously. So if we just simplify perfect square roots, we should all know how to do this. So square root of 16, what number times itself equals 16? So 4. Jumping over then, if there is a number in front, what this means is when they're right next to each other, 2 times the square root of 121. So the square root of 121 is 11. So 2 times 11, so our solution is 22 for this. All right. Same thing with this next one. So we're doing 6 times the square root of 289. Now that is not on our list, but it is actually a perfect square root. It's 17. So 6 times 17, and our answer is 102. And then last one, so square root of 400 is 20. So we're going to do 3 times 20, which is 60. So those are all perfect square roots. Our solutions or our simplified answers do not include any square root signs or radicals. So now we are going to break down and simplify radicals where they're not perfect square roots. So step 1, we want to find the largest perfect square. So that's why that list of perfect squares is extremely important. We're looking for factors of the radicand. So that number under there, we're trying to figure out which number is divisible by one of those perfect squares. And we're going to break down the radical using that number then. We're going to take the square root of the perfect square and we're going to pull it out front. And we're going to take it out of the radical in step 2. And then whatever is left, that factor that's left that's not a perfect square root, that stays under the radical symbol. Okay? So let's take a look at this first one. Square root of 32 doesn't come out to a perfect whole number. So we're trying to figure out factors. What times what gives us 32? But we want one of the factors to be one of these from our list of our perfect squares. So we could do 4 times 8, but there's a bigger number that goes into it. We could do the square root of 16 because 16 times 2 is 32. So all we did was we broke that radical into 2. It's still the same thing. And then what we can do is actually find the square root of 16, which is 4. So it is now outside of the radical. But we still have the square root of 2 where we don't get a perfect whole number. So we're going to leave it as 4. And then right next to the 4 is the radical 2. So 4 times the square root of 2, or 4 radical 2. Same thing. Okay, now if you didn't see that right away, maybe like I said in the beginning, 4 is also a perfect square root. So maybe you did 4 times 8, and then we could pull out the square root of 4 is 2. And then this is an actual correct answer, but it's not fully simplified because the square root of 8 is divisible by 4. So we could actually break this square root of 8 into 2 more factors, pull out another square root of 4, which is 2. So we'd multiply it to the front, leave the square root, you're going to get the same thing, 4 times square root of 2. But I was just showing you in case you didn't see the 16 right away and maybe you used 4. So I'm going to erase that just so that I don't confuse you, but you may run into that situation. So let's try it again. 180. So we're trying to figure out what times what equals 180. We're going to keep both of them under square roots. We could, let's see, 16. And really, if you aren't sure, you could just take that 180, put it in your calculator, and start dividing. And start dividing by this list of perfect squares. The highest is actually 36. So 36 times 5 is 180. And 36 is a perfect square root. So we can simplify that to the whole number 6 outside of the radical, and then square root of 5 is still left. So 6 radical 5. Right, let's do it again, 147. So we would start brainstorming. This one I don't know off the top of my head, so I'm going to use my cheat sheet. So it is actually 49 times square root of 3. That is our highest perfect square. So then square root of 49 is 7, and then square root of 3 is left with the radical. 175, so I know 25 goes into it, and I know 25 is a perfect square. So it'd be 25 times 7, and an easy way to check to make sure you got the biggest perfect square factor is to look at the other factor, the square root of 7. Or that factor of 7, it's prime, so we can't break 7 down any further. So I know that I found the largest perfect square. So square root of 25 is 5, and then leave square root of 7. All right, I'm going to pause there, and actually, I'm going to jump down before we pause, because we haven't done one where there's a number out front. So remember, this means 2 times square root of 54. So we're going to break down the square root of 54. We've got 9 and 6, and I think, 6. The only factors are 2 and 3, and 2 and 3 are not perfect squares. So 9 and 6 are broken down. Now, what happens here is the square root of 9 gets pulled out to a 3, but we already have a number in front of the radical symbol. So now we have to multiply those together. So we'll do 2 times 3, and then that radical 6 stays since we can't simplify it anymore. So 2 times 3, we'll get 6, and we'll get 6 radical 6. Okay? Finish up that question number 9, and then let's see, and try out those last 4 on the back as well. And we'll pause there and see if you are on the right track with those. Right? Square root of 48, 16 is a perfect square, and it goes in to 48, so 16 times 3 is 48. So we'll get 4 radical 3. Right, then on the back side, now we have some numbers out in front of the radicals. So we have -5, and then I'm going to break down square root of 150 into, let's see, 25 and 6. And then that way the square root of 25 is 5. So we'll do negative 5 times 5. And then we still have that radical 6. So we get negative 25 times the square root of 6. And that is simplified. Number 12, so we have 8 times, I'm going to break 128 into 2 factors. So 64 is the largest. That is a perfect square. 64 times 2 is 128. So we'll do square root of 64, pull that out, and then we'll leave that radical 2. So we end up with 64 times square root of 2. And number 13, so negative 3 times square root of 28. The only 2 factors are 4 and 7, where one of them's a perfect square. So square root of 4 we can pull out as 2, so we'll have negative 3 times 2 times square root of 7, so negative 6 radical 7. And last example you did, ooh, this is a big one, 384, so 2 factors. The largest factor would be 64, that's a perfect square. 64 times 6 is how I got 384. So then we'll have 4 times 8, the square root of 64. And then the radical 6 stays. So we wind up with 32 times square root of 6. So there we go. There is simplifying radicals. All of those just had numbers. I'm going to pause there. We're not going to do cube roots quite yet. It is the same process, but then notice we have an index of 3. So these we are looking for what number times itself 3 times. 2 times 2 times 2 gives us that number under the radical sign. So the cube root of 8 would be 2. Now, I'm going to pause there. We're not going to get too far into the cube roots because I want to make sure we master the square roots first. So there is simplifying radicals.